For the homework for this week, I'd like for you guys to start off by adding guide geometry to your sticky input OTL. So basically I just want it to display the geometry that the boxes are going to stick to. In this case it's this ground here. And then I'd like for you guys to add to your create OTLs, I'd like for you to add a handle. So I can move it around in the viewport pretty easily. And then the tricky part with this is that I want to be able to rotate the box normally. And you'll see why that's a bit tricky once you try to add that. You might have to do some odd things with the way that the parameters are promoted in order to make this work. And then I can also scale it, and notice that my rims here stay the same size as I scale. The other thing I'd like you to notice is that I have my rim thickness and extrusion distance in the toolbox here, which makes them really easy to change without having to come back over here to the parameter pane. So I'd like for you guys to add that as well. Once you're done with that, go ahead and upload so that we can take a look at the way that you guys are going. And then there's another project. So leaving your box setup behind for the moment, if I come back out here to object level, it's another kind of interesting project that I have for you guys. So in this case, I just have this sphere here, and on this, make sure that the primitive type here is set to polygon, so it'll be important later. And then a points from volume node, which creates a grid of points inside of the sphere. And then I have a point jitter, which just makes the points kind of randomized. And then I have this Voronoi fracture node. So the point jitter plugs into the second input, and the sphere plugs into the first input, if you don't know the way that this node works. What that does is just cut it up into a bunch of more or less equal-sized pieces, depending on where these points are. And then I generate a point ID here, or a chunk ID, on points, with a connectivity swap. And then I'm doing this group by bounding object here. And what I've got here is I've got a sphere. If I translate, and it's just going to group all the points inside the sphere. And the way that you make it do that is you go to this group node here, and then we're under the bounding tab here, you say enable, and then set it to bounding object points only. Make sure that the entity is set to points, and under number, make sure that this enable is turned off. And then notice that my kill group is called, or my group name is called kill group here. The reason why that's important is because this is your project, this kill chunks OTL. So basically you give it a group of points, and you give it an attribute which represents an ID for each chunk, which is what is generated by this connectivity swap. And it kills entire chunks based on that. So you'll notice that with my kill group here, if we just move this over here, if I just make a delete swap and plug it in and then display it, if I just do kill group and set it to points, you notice that it's not killing the whole chunk, it's just killing exactly the points that I have grouped. So what this node does is it kills the entire chunk. So any chunk that has a point that's inside the kill group, it will kill that whole chunk. So if you watch, if I move my sphere around, you can see that it blows the whole chunk away whenever the sphere encapsulates one of the points in a chunk. This is a really useful tool that you can have in production because if you're doing a sim and there's a piece that's behaving oddly, or maybe a group of pieces that are in places where you don't want them to be, you can just delete all of those pieces and you don't have to worry about making sure that the whole piece is deleted. Now, this requires using a part of Houdini that a lot of people are not familiar with, or rather a feature of Houdini. So, again, I'd like for you guys to give this a try on your own and see if you can figure out how to do it. And if you can't, come back to this video and I'll give you a hint. Okay, hint time. So, the key part of this OTL, and this is the feature in Houdini that a lot of people aren't familiar with, on the point SOP, there's this match by attribute toggle. If you turn that on, you can give it any arbitrary attribute name, or even an expression that generates an attribute name. And then what it'll do is, for each point coming into the first input, it'll use this attribute to match against points coming into the second input. So if I were to do something like tx2 here, at this point it would go and find the first corresponding point that has the same ID attribute, and it would set the x position to that point. If you have multiple points coming into the second input, all of which have the same attribute, which is actually what we have coming in here, it'll just grab the first one that it finds.